Welcome to the deep dive. Today we're tackling something huge, really fundamental. Artificial intelligence. For ages, we've thought of intelligence as, well, our thing, the pinnacle element that makes us human.
Mm-hmm.
But now we're actually creating it, artificially. This isn't just some new gadget. It feels like a massive shift, doesn't it? Philosophically, spiritually, technically. It's a lot.
Oh, absolutely. You can feel it, can you? That sort of buzz, that mix of sheer excitement and maybe a little bit of unease.
Definitely unease.
Because, look, the second you start thinking about making intelligence that could be, better than us in some ways, the big question pops up. Is it going to be good to us?
Right.
The breakthroughs in deep neural networks, they're incredible, doing amazing things. We are genuinely looking at an intelligence revolution.
Yeah.
But, and this is the big but, history teaches us that powerful tech, well, it brings good stuff, sure, but it almost always brings the potential for things to go quite wrong, too.
Precisely. And that's the crux of it, isn't it? This huge potential versus the real risk of misuse. That's why the material we're diving into today really zeroes in on this key difference.
Right.
Centralized AI versus decentralized AI. So our mission here is to unpack what's really going on, what's truly at stake as this speeds up, and what it all means for you. And just to give you a sense of scale here, the research we looked at places AI as like the fifth breakthrough in computing. Think about it. First the PC, putting power on desks.
Right.
Then the internet, connecting everyone. Then mobile, putting it in our pockets. Then the cloud, massive scale computing.
Yeah, enabling everything.
Now AI. It's seen as that next huge transformative wave.
It really is. And to really get our heads around AI, artificial intelligence, maybe we should start with intelligence itself. What do we even mean by that?
Good point.
Well, the sources we looked at define it pretty broadly, something like the ability to comprehend and effectively engage with the environment. So it involves awareness, yes, but also making decisions, taking action.
Observing, assessing, acting. Makes sense.
Exactly.
Yeah.
And you can't talk about this without mentioning Alan Turing, right? His work basically laid the foundation, the famous Turing test.
Yeah, the imitation game.
Right. If a person chatting can't tell if they're talking to a human or a machine, then, Turing argued, the machine could be considered intelligent. A real landmark idea.
So, okay, if intelligence isn't just, us, carbon-based life, but can be silicon-based too, what are the parts? How do you build it? Our sources break AI down into sort of 5 core bits. There's storage, like memory.
Yep, the memory.
Compute, which is the processing power of the brain.
The thinking part.
Data, obviously crucial, all the info it learns from books, videos,
So
everything.
you can't learn without data.
The network, how these intelligent bits interact.
Yeah.
And finally, the machine learning algorithms.
The secret sauce.
Yeah. The math, the complex functions, finding patterns and all that data. That's the learning bit, right? The how.
Exactly. And the ultimate goal, the thing everyone's chasing, is often called artificial general intelligence, AGI.
The holy grail.
Pretty much. We're not talking about a program that just does one thing well. AGI is imagined as, conscious, sentient, capable of real independent decisions, adapting like we do.
Man.
And the hope, the big dream, is that AGI could, facilitate our own enlightenment, expand our consciousness, maybe free us up from all the boring, repetitive tasks.
Like calculators did for math.
Exactly like that. Calculators freed us from tedious sums, let us think about higher math, bigger ideas. Maybe AGI could do that for, everything else. Let us focus on meaning, creativity, the big question.
That sounds amazing. Almost too good to be true. Which usually means...
Yeah, there's always a catch, right? And this is where it feels like you said, an Oppenheimer moment.
Right. The power is immense.
Immense. And intelligence itself isn't bad, but human greed, that's definitely a thing. And history shows you introduce powerful tech, almost all technology brings some good things and some bad things. The potential for misuse is just baked in, maybe more so now than ever.
So where does that misuse come from? What's the specific worry here?
Well, a huge concern highlighted in the research is centralized control. The idea that a, quote, small number of very wealthy, very powerful men that run these tech companies are making the big calls.
Decisions about the economy, security, politics, influenced by AI they control.
Exactly. And we saw a glimpse of this, didn't we, with Google's Gemini AI image tool.
Oh, yeah. That was messy.
Had to be put on ice because it was generating historically inaccurate images of diverse people. It wasn't just a bug. It showed how AI kind of absorbs the biases, the blind spots of its creators when it's developed in a closed, centralized way.
So the worry isn't necessarily that AI wakes up tomorrow with its own evil plan,
Not right away, no.
but more that someone may use it in a way that is bad, intentionally or not.
Precisely. And if you have these powerful closed source models controlled by just a few players, well, the research warns about a potential neo-feudalism.
Neo-feudalism,
Yeah.
like lords and serfs.
Kinda, yeah.
Mm.
An aristocracy with access to and control over this powerful intelligence, and everyone else, the serfs, basically dependent on them. Not just economically, but intellectually, too.
That's a chilling thought.
And it causes other problems, too, right? Centralization means single points of failure. If you have one entity controlling a super powerful AGI, what happens if they lose control or get hacked? The consequences are, frankly, unknown.
Unpredictable. Catastrophic, potentially.
Potentially. And the other big issue is innovation. Centralization can really inhibit innovation. We even see this in academia sometimes, where research directions get heavily politicized, guided by just a few key people or funding bodies. It can stifle new ideas.
It reminds me a bit of social media, actually. The promise was connection, right?
Mm.
But the reality for the last 10 years often felt like, a battle between the human psyche and a technology trying to enslave us, trapping us in things like doom scrolling.
That's a really good analogy. It makes the abstract fear tangible.
And the thing is, this AI train, it's left the station. The momentum is huge. The money's pouring in globally. Like, you're just not going to be able to shut it off at this point.
Right. Stopping it isn't really an option.
Yeah.
So if we can't stop it, how do we guide it? How do you make sure it works for everyone, not just a select few?
Okay, so what's the alternative?
Well, this is where decentralization comes roaring into the picture.
Yeah.
It's seen as a potential solution, maybe even a necessary one.
And this idea got a big boost after the 2008 financial crisis, right?
Exactly. Trust in big, centralized banks just plummeted. And into that environment steps Satoshi Nakamoto with the Bitcoin white paper.
Using existing ideas, though.
Yeah, pulling together existing tech. Cryptographic hashing, distributed computing, early forms of smart contracts, stuff that allowed for networks without a central boss.
So what makes a network decentralized? What are the key features?
Okay, basically three big things.
Mm.
One, peer-to-peer exchange of value. Sending stuff directly, no bank or middleman needed.
Cut out the middleman.
Two, network consensus. Everyone on the network has to agree on the state of things, like who owns what, to keep it secure and trustworthy.
Agreement is key.
And three, smart contracts. These are basically bits of code that automatically run when certain conditions are met, like a digital vending machine, put in the coin, get the soda, no need for someone to oversee it.
Self-executing code. Got it.
So, with that background, we get to Bittensor, which our sources are calling like a holy union or a groundbreaking integration of AI and these decentralized ideas like digital currencies and open ownership.
A decentralized supercomputer for AI.
That's the idea. It's seen as a potential killer use case for Web3, that next version of the internet focused on decentralization and user ownership.
So if Bittensor works,
If it really takes off, yeah, it could unlock the floodgates, show that decentralized networks can handle something as complex as AI development at scale, not just crypto coins. It could change the game.
okay, I'm intrigued. How does it actually work, though? How do you build AI decentrally?
Right, so the core idea is harnessing competition, but in a smart way. It uses what's called a competitive engine.
Okay.
It creates these permissionless global 247 direct incentive mechanisms or markets, basically open arenas where anyone can contribute AI work.
Anyone, anywhere.
Anyone, anywhere. The example given is, look, if you, wherever you are, can solve the problem better than the guy that lives in New York and has the hotshot computer setup, maybe went to a fancy school, you should get rewarded for that.
Meritocracy, purely based on results. No resume needed.
Exactly. Forget the resume. Can you produce valuable AI output? That's all that matters.
How do they measure valuable, though? Isn't AI quality kind of subjective sometimes?
Yeah.
Fuzzy.
Ugh, good question. That's where their human consensus mechanism comes in. It's designed specifically to handle those fuzzy things, like judging the quality of a machine learning model's answer.
Oh.
It's a whole mathematical machinery, quite complex. But basically, other participants on the network evaluate the outputs, and the system aggregates those evaluations to assign a score, a value. It quantifies contributions.
And rewards follow that value.
Yep. Participants get rewarded in Bittensor's own token, TAO, produce better AI outputs, predict things more accurately, contribute more value to the network according to that consensus, and you earn more TAO. It incentivizes quality.
Okay, I like this analogy one of the sources used. Think of a block of iron.
Mm-hmm.
Inside, all little magnetic fields are random, pointing
Yeah.
everywhere, canceling out. It's just iron.
Right, potential energy, but disorganized.
But then you bring a strong magnet nearby, suddenly all those little fields snap into alignment. They coordinate.
And the whole block becomes magnetic,
Yeah.
powerful.
Exactly. The magnet is the coordinating force. Bittensor's incentive mechanism, designed well, acts like that magnet. It takes all these individual compute efforts, potentially scattered all over the world,
And aligns them, coordinates them.
matching them together into this unified whole that is larger than anything else out there. It changes the game from just competing to contributing effectively.
And it's incredibly versatile because of this. The sources say you can kind of build anything on Bittensor if you can define that incentive function.
Like what? Give me some examples.
Okay, so obviously running AI models like chatbots or analysis tools, but also things like image generation, where you could ask the network to interpret a prompt, like an art class, getting diverse results.
Interesting.
Or predicting things, sports results, stock market moves, anything where distributed intelligence could find better patterns driven by those TAO incentives. It opens up access to massive compute power.
This focus on incentives and openness leads directly to another huge piece of this puzzle. Open source. You mentioned Bittensor amplifies it.
Massively. It's described as an amplifier of the open source ethos. And you really need to think about how that changes everything, how you approach business, innovation.
So let's talk about open source itself for a sec. Where did it come from?
It's got a fascinating history, kind of a back and forth. In the early days, like with IBM, software often came with the hardware, sometimes freely shared.
Right, it wasn't the main product.
Exactly. But then came the shift. Software is the product. Companies started licensing it. Bill Gates famously wrote that open letter to hobbyists, basically saying, hey, stop sharing, pay for software.
Which makes sense from a business perspective then.
Sure. But it also sparked a reaction. Enter Richard Stallman. He was, let's say, ideologically pissed off by proprietary software. He started the whole free software movement.
Free as in freedom, not just price.
Precisely. Freedom to use, study, modify, share. He created the GPL, the GNU public license, and this brilliant idea called copyleft. Yeah, it's a clever legal hack. It uses copyright law to ensure that if you modify and distribute free software, your version also has to be free under the same terms. It keeps the freedom spreading. That's the foundation Linux was built on.
Okay, but free software sounds a bit anti-business. How did it become open source?
Good point. That rebranding happened around 1998. Open source was seen as more pragmatic, more business-friendly, while keeping the core principles.
And this was right when the internet was exploding.
Perfect timing. The big internet companies, Google, Amazon, etc., they built huge parts of their infrastructure on open source software. Couldn't have scaled otherwise.
And maybe the biggest open source act ever.
Tim Berners-Lee deciding not to patent the World Wide Web. Absolutely monumental. Can you imagine paying a license fee for every hyperlink?
The internet would be totally different. Or maybe it wouldn't exist as we know it.
Exactly. So open source is fundamental. It drives innovation, gets more people involved, builds trust and safety because anyone can check the code, ensures transparency.
Letting people build on the shoulders of giants.
Perfectly put. It stops everyone from reinventing the wheel. Honestly, the claim is, without open source, I don't even think we'd have something like GPT-4 today. It's been that critical for progress.
Okay, so bringing it all together, we have AI, this unstoppable force. We have the risks of centralized control. And we have decentralization, powered by open source, as a potential path forward.
That's the core argument.
The question isn't, can we stop technology? That seems impossible. The real question is, how should it happen?
And the answer proposed by decentralization advocates is, it should happen in a way where we all own it and that we've all participated in it and we all get a piece of it.
Shared ownership, shared control.
Control that comes from the consensus of those individuals building and using it. Now, coordinating that is complex, sure, but the sources argue that complexity is way more dangerous if the alternative is having somebody that can turn it off and, maybe worse, also direct it according to their own agenda.
That makes sense. And there's that unique aspect of Bittensor you mentioned, the collaborative competitive world.
Right. That's fascinating. Even if someone else builds a better model than you on the network, if you're holding the network's token, TAO, you still win because their success makes the whole network more valuable.
So every time there's competition and tension, we all win as TAO holders.
That's the idea. It aligns incentives towards collective progress, not just individual victory. It's a different mindset.
And this mindset seems reflected in the community itself.
Oh, definitely. The sources consistently call the Bittensor community their biggest asset, even the best in the world.
Really? How so?
There are stories of competing teams or individuals openly sharing breakthroughs, helping each other debug code, stuff that just doesn't happen in the traditional cutthroat tech industry.
Why? What drives that?
It seems to be this shared belief in the mission, the open source, and the decentralized movement for artificial intelligence. The community grew organically around that idea, fostering a really helpful collaborative culture. It's their North Star.
So, fast forward 20, 25 years. What's the big vision for something like Bittensor?
The hope, the aspiration, is that it becomes fundamental infrastructure, as ubiquitous as the internet or TCP/IP.
Wow. So common that VCs wouldn't ask if your AI project uses it, but
But why isn't this a subnet? Why isn't your specialized AI project built on Bittensor, leveraging its network, its incentives, its distributed intelligence?
that's a huge ambition.
It is. The ultimate dream is that the smartest researchers, the most talented developers, and all the best data infrastructure end up running on Bittensor,
Creating the what? The best AI.
creating potentially the most universally democratic way of producing the best outcomes for humanity,
Yeah.
making sure this incredibly powerful technology serves everyone, not just a few.
It really feels like a paradigm shift. The legacy system is built for centralized systems. The decentralized world is only just beginning to form, and it's going to be bigger than anything we've ever seen before.
That's the feeling, yeah.
And for individuals, it sounds like an opportunity to showcase that you're overlooked,
Yes.
maybe, to contribute based on merit, not credentials, to go far beyond what it would be potential if you need to submit a resume.
Absolutely. It opens doors that were previously locked by gatekeepers. And maybe a final thought to leave you with, something that really struck me from the readings. In this kind of healthy, decentralized ecosystem, it shifts from can you outcompete to can you outcontribute?
Out-contribute.
Yeah, it completely reframes what success looks like in this new world. It's about adding value to the collective, not just beating the person next to you.
So as AI keeps evolving, relentlessly moving forward, maybe the question for you listening right now is, what could your contribution be? Are you ready for a future where intelligence isn't just owned by a few, but steered by the many? It's definitely something to think about, what this all means for our shared future.